Alright guys, here we are, staring down the barrel of a GS450h transmission. This transmission has two electric motors inside of it, and we're going to talk about MG1, motor generator 1, which sits in front of the transmission, acts as a starter, and it spins the transmission's input shaft to help the gasoline engine to start. Acts as a starter. But there is a way to make the front motor spin the output shaft the same way that MG2, motor generator 2, in the back of the transmission spins the output shaft. To do that, we need to do what is called locking out the input shaft, this piece right here. Now, those of you who know things about transmissions may know that there's other means of achieving the same thing. By welding the gears, the planetary gears inside of this transmission. This is a 2-speed planetary gear transmission. I have no idea what that means, and I am sure not going to take this transmission apart to weld anything inside of it. I can do some booger welding, but I am not confident enough or have the desire to weld the gears inside of it. That seems very permanent, very unreversible for whatever reason we may want to reverse it. Now there's a couple ways to lock out the input shaft. We're going to I'm going to show you the quick and dirty way for testing, but I'm not really going to even use this method, but I'll just show you so you can get the concept of what we're trying to do. So one of our favorite tools in a toolbox, I'm sure all of you have one of these. These are just vice grips. I've made sure that these are very loose. I'm just going to put them on here for demonstration purposes. I hate using vice grips on pretty much anything other than pulling nails out of an old fence, okay? So I'm going to be gentle, and I'm going to put them on here on this input shaft. Very little pressure. So yeah, please don't beat me up in the comments too much that I'm ruining those splines with very gentle pressure. And then all we really need is a bolt and a nut here, and we'll feed it through just so you guys can get the idea, get the concept of this. I don't think it matters which hole it goes to really. Put it through, put a nut on it just to hold it in place, and assuming we're in what I think may be reversed to spin it that way, which would be, depending on your position, counterclockwise, if you will, if you're sitting in the car, is it? This will do it. So we will achieve something like this in a nicer way because we're not barbarians. We're much more civilized than that. So I'm going to try to make something that accomplishes essentially the same thing. So let's talk about locking out the input shaft of this Lexus GS450h transmission so that the front motor spins the output shaft along with the rear motor, MG2. Okay? This transmission has two electric motors inside of it, one in the front, a smaller motor that acts as a starter, and then its job is essentially done. It does not power the rear wheels when in electric mode. The rear motor, the much larger motor in the rear, powers the rear wheels and spins the output shaft. The rear motor is pretty impressive. It's good for 200 horsepower. So I assume that the one up here, which is a bit smaller, is good for at least another 100. So if we could get both motors to spin the output shaft, we could achieve 300 horsepower, which in my opinion for a street car, a true street car daily driver is quite impressive. So let's talk about how we're going to keep the input shaft from spinning. When I bought the transmission, I bought a few other items with it, like I've shared in the other videos. I bought the drive shaft, and on this side I actually bought the flywheel, or what they're calling the flywheel. So here we have it. Alright, it's pretty heavy. The reason I bought this is because I know that I'm guaranteed that these splines will fit directly on there perfectly. So I thought, let's get this. So straight away what you'll notice that there's two bolts on here that seem to be holding two pieces together. So let's take this apart and see what we get, because I'm telling you right now this thing is really heavy. If I had to guess, at least 25 pounds, maybe 30, 35. This transmission is already a unicorn since it has electric motors inside it. So this is a bit different. This isn't just a pressure plate like I would see in a turbo 350 on a Chevy. This is sort of a combo, I think, and correct me if I'm wrong, I'm out of my jurisdiction on this, I'm no expert by any means, but it seems like this is a little bit of a marriage between a flywheel and a clutch disc. But look at this. That was easy. So we can remove the disc here from the flywheel itself, and we don't need the flywheel, okay? The flywheel has no splines, okay? So it's no good to us. It's just extra weight. I'm telling you, this is 25 pounds easy. Set that aside. And what we want is we want the pressure plate or the disc, whatever you want to call it. It has the splines on the inside. And now we can put it on there, and it fits perfect. So we will fit it on here and then attach it somehow to the outside. Alright, gentlemen, so we're going to go and show you some actual action shots here of me actually doing something. So we need to drill out these rivets. You can see them. 3, 6, 9, 12 of them. That should be fun. We've talked about tip maintenance before. Always clean your tip and always wet your tip. We're using some Aunt Jemima pancake syrup there. If you have the Canadian stuff, even better. Real maple syrup. So well, looks like it was doing better dry. Actually, when it comes to jobs like this, I learned that cordless power tools are useless. You gotta go corded. So what we got here, where am I? What we got here is an old Milwaukee drill. I think it's 3/8. We're going to start with that. It's corded. Pronounce it works. I'll be honest with you, I don't know how to sharpen drill bits. I'm not proud of that. That's something that I need to learn how to do. machinists know that that drill bit is dull because it's not supposed to have little shavings. It's actually supposed to come off in a big strands. So I'm going to try a different drill bit. And this thing is wobbly. Looks like the Japanese engineers didn't think of us building electric cars out of their flywheels or pressure discs, so they didn't account for balance on that. That's alright. Oh, look at that. Wow. One came out. Ooh. I was worried about that thing being hot, and it was sharp instead. But there, where are we? One down, 57 to go. Now I do have one of these gizmos, tool sharpener, old school. We're going to give that a try. This video brought to you by the Headless Machinist. We find the hole it fits into, put pressure on it. I think we can press it through the inside. Insert bit in the smallest hole, rotate bit clockwise until it stops, lean bit toward index line. Sorry, we push it to the outside, but whatever. So here we go. The smoke. Let you guys be the judge of this. I have no idea what we just did. The smoke was just the oil burning off. So in case you haven't noticed, I sharpened my drill bits just by airplane. In case you haven't noticed, the way I sharpen my drill bits, I just reach for new ones. And eventually I think I'm forced to actually sharpen one. So this drill bit's pretty good. Kind of give it a little bit of a pilot hole feel there. And we can try to hit it with big Verta here. Oh, got another one. There we go. Clean this up a little bit. Maybe we can see what we're doing. So, I think this one's all done. That's 3. This one is 2 out of 3. This one is none out of 3, and this one is 1 out of 3. Now that we can see it, so the middle one's gone. So 1, 2, 3, 4, 5, 6. 6 out of 12 puts us perfectly at 67.2%. So we'll just keep hunting for drill bits that might still kind of work. Let me show you some quality tools I'm working with here. Here's a punch. Does that look? Can you see that? How straight that is? I doubt I can punch these out on the table. course, the one that's ideal is all bent to hell. Hey, it worked! So we got one, 11 to go. That's two. Okay, that's three. Three are out. So I think I'm onto something. Just gotta drill out the rest. Okay, that's 6. Seven are out. Look like little 22s. More drilling. Fun. Okay guys, so we're back from our drilling station, and after hours and hours and hours of drilling and a couple beers, here's what we have. So this is the actual, I would call, flywheel with teeth on it. I'll weigh this later just out of curiosity, but we don't need it. So we don't need that. This is the outer ring of the actual pressure plate, I think it's called, clutch plate. We don't need that. Bunch of internal braces, don't need that. Clutches, spacers, gizmos, don't need that. Springs and woolly wonkas, don't need that. What we do need is the Karate Kid approved ninja star here. And check that out, man. I might get a tat of that. Pretty cool. So this is all we need. This is going to go on here. However I do this, I think this protrudes enough that I'm going to need some spacers on there. I actually have one sample spacer here. So depending what side I go with, I could put a spacer on there. But basically I would do something like this with a spacer there either side and just bolt this on. Yeah, so something like that. So I drilled these holes out so they're round because they're a little bit oval from the factory. So now they're perfectly round. So we're gonna try to get on center of these two holes so that I can do my brackets. But that looks pretty darn close to being on center. Wow. Try that. Right guys, so after hours and hours of drilling, I've got what I think is a partial solution to keeping the input shaft from spinning. So this is obviously going to go on there like that, but then we need a bar to keep it, to make it go across. So I came up with this, and then let's see if I can even remember where the holes were. Here's the other one. So I'm using spacers. This isn't going to be
the final solution here. This is just temporary for demonstration. That's the excuse I always use when I'm doing things half-ass. So like that. I think here. Those, or maybe these. I think I was thinking of using these holes right here. Yeah, so I need to punch those. Need to punch and drill out those. So I'm going to use these hole puncher pretzels. Can I show them to you? They got these pointy bits. And if you get the right size, it will fit in the hole, which is not that one. Now, me going for this level of precision is just comical, I know, but kind of practicing here. Oh, great. Yep, that this orange thing is right in the way. So maybe that did something. Probably nothing. It gave us a little dot. So we're going to drill that next. Welcome back to the Swiss cheese garage, where we take metal with holes in it and we drill more holes in it. So the point of this is to make a lockout mechanism for the input shaft of the GS450h transmission. So this piece we cut out of the pressure plate, flywheel, whatever you want to call it. And we're going to mount it like so to the cross member, if you will. This is all temporary, really. It's what I like to say when I'm just half-assing things, is that this is just temporary. And then 6 years later, it's still running. I don't know why I'm making this tight, but I'm making it tight. So hopefully this aligns. Hopefully I remember where it goes. That's one side. And So there we have it. That's how you do it. One locked out transmission. Let me show you how quickly things escalated here. I mean, there's junk all over the place. Another drill sharpener there. Yeah, but look at this. This is just all of this. So all of that, ladies and gentlemen, just to drill 4 holes. And this moron here is going to build an electric car. So, not sure if you guys can see these digits on this guy. But we're gonna weigh the flywheel. Oh, come on. £14.7, I think it is. There it is with all the crap. Ah, 27.8 pounds. That's how much we removed. So that's how much we removed. That's not what the whole thing weighed, because we kept the centerpiece still. So it's like a 30-pound piece. I was pretty close. It's close to my bench max, so I know exactly what 30 pounds is.